Very good afternoon.
uh, Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram. First of all, we would like to convey our thanks for sharing your valuable time. Firstly, you are sharing your valuable time. Later, you are sharing your valuable knowledge with us. So, first of all, from the bottom
Pleasure,
of our hearts, we will convey thank you, sir. Sir, before entering into the
pleasure is mine.
session, yes, sir. Let me take the privilege to introduce you, sir. It is my great honor to introduce Dr. Santosh Krishna BV. Dr. Santosh Krishna is working as an associate professor in the Department of Computer Science and Engineering at New Horizon College of Engineering, Bengaluru, Karnataka. He received his doctoral degree from Anna University, a state government university in Tamil Nadu, India, in the area of biomedical image processing using machine learning algorithms. He has 12 years of experience in teaching and research. He has authored 9 textbooks in the area of communication and networking. He has published 30 papers in Scopus, Sci-indexed journals, and conferences. He is an active reviewer in many reputed Sci-indexed journals. His area of interest include medical image processing, communication network, and security. Sir, really, it is a great honor to have a great personality as a resource person in this faculty development program, sir. Sir,
Pleasure is
now
mine,
I
sir.
request you, sir, now I request you to share your thoughts in research opportunities in computer vision and image. Now
Sure,
the
sir.
platform is
Thank you, sir.
yours.
Thank you, sir. Thank you for the good introduction, sir. My screen is visible, sir.
Yes, sir, it is
Yes,
visible,
yes,
but it is not in the
yes, sir.
presentation mode, sir.
Okay, that helps.
Yes, sir.
Now it's
Yes,
fine,
sir.
sir.
Now it is.
Moving
Yes,
fine.
sir. Now it is.
Fine, sir. Fine, sir. Thanks for the opportunity. The second time to talk with Vishnu Engineering College for the FDP program. I thank Kiran sir for giving me a wonderful opportunity. So now my research topic for today is research opportunities in computer vision and image processing. Many of us are confused with normal image processing and the computer vision. What is the difference between this computer vision and image processing? How these two things are related? And what are the opportunities to do the research? What is the scope of doing the research? In which areas we can focus? How to narrow down the research in the computer vision and image processing? All these topics let us discuss today. And agenda for today is what is computer vision? How does computer vision works? What is image processing? What is the difference between image processing and computer vision? What are the types of image processing applications? And what is the current trends in image processing? And what are the topics for doing research in the computer vision and image processing? Then I'll conclude my remarks. It is very short presentation I have done. It will be less than 40 minutes, I believe, so that we can give opportunity for other speakers also to continue with their thoughts. So what is computer vision? It is a field of artificial intelligence. As previously Ajay sir is talking about the artificial intelligence, it is a continuation of the artificial intelligence again. Computer vision is a field of artificial intelligence which enables computers and systems to derive a meaningful information from images. So we know image processing is a very older field. So now with the advent of artificial intelligence, how some information can be retrieved from the digital images or videos or any other visual inputs and can take some sort of recommendations based on the information. For example, if AI enables computers to think, the computer vision enables them to see, observe, and understand. Statement is good. I'm repeating again. If AI enables computers to think, computer vision enables them to see, observe, and understand. So if AI can able to provide some power of thinking, the computer vision enables them to see, observe, and understand. So Computer vision works much as a human vision. Basically, this computer vision was derived with the base of the human vision, except humans have a head start, which means that humans will think up first, then will do something, whereas machines will be able to do the same thing with the help of some sort of programming. Human sight has an advantage of lifetimes of context to train how to tell objects apart. For example, right from our age when we born still our end, we are able to train continuously train ourselves for the progress, whereas machines, unless we update, they are not going to get updated. So computer vision trains machines to perform what are the functions we do, but it has to do it with much lesser time with help of cameras, data's algorithms. For example, if I am visiting a doctor may take some 10 minutes to diagnose what is the problem, whereas if I'm having a machine in the place of that, I'll be able to get my diagnosis within some 2 to 3 minutes. That is advantage of computer vision and more accuracy when we are training the machines with a more number of inputs. So how does computer vision works? The visual can able to see that how a computer vision and human vision are one to each other, how they are going in line with line. For example, the input is going to be the same, whereas in the place of eyes, we have a device called a sensing device, which will capture the image, and we have a brain which will interpret what is happening there. Whereas here we have an interpreting device which will do all sort of interpretation and give us the output what is there in that diagnosis. For example, in the plate consists of fruits. What are the fruits there? Visually, we are going to see with the eyes. Then the brain will able to interpret and be able to tell what are the fruits in that bowl. Okay. So what is the computer vision, human vision are almost similar. Whatever things we are doing with the human vision, we are going to duplicate with the help of the computer vision. The main purpose is to make it easier, simpler, and more accurate. So computer vision needs a lot of data. See, with why this machine learning, deep learning, all these things are coming into existence now. Is it very new field? No, it is there for n number of years. Now, because of data, we have large number of data. So with a large number of data, we can able to train the machines more. When training is more, accuracy will be always more. For example, if I'm teaching a kid, it is a banana. If I'm seeing showing the kid only once, the kid may forget it. So if I keep on showing various types of fruits to the kid will able to recognize the fruits very easily. Similar way, we are training a machine like a baby. We are giving them more input so that it will learn it in a very quicker way and very accurate way. So the computer will run analysis of data over and over until it screens ultimately recognize the images. For example, to train a computer to recognize automobile tires, it needs to be fed with vast quantities of tires. The same example as I told you with the help of baby and the fruits, right? Very two essential technologies are used to accomplish this. First one, a type of machine learning called as a deep learning and a convolutional neural network. So can somebody tell me a difference between what is machine learning and deep learning? Any audience? What is the main difference between machine learning and deep learning? Someone?
In deep learning, the middle layers can be plenty, but in machine learning, it is not based on the neural networks. Deep learning is based on the neural networks, basically.
Yes, partiality is correct, madam. Thank you. So machine learning and deep learning almost will go same. But whereas in the machine learning, we have a limitation of layers, whereas in deep learning, we'll be able to train the machines with a number of layers, which means that if in the case of machine learning, if my accuracy is 60%, if I'm adding some sorry, if I'm adding n number of images inputs, it will be more accurate. For example, in any if I'm taking a room, if I'm taking a picture of an audience, I need to segregate male and a female from that audience. So if I am taking some input features, what is the features of a male, features of a female? If I am giving a machine more number of features, more number of layers, then my accuracy will be obviously more. Similarly, the deep learning, when we add n number of layers, so it may be complex, but we'll give an accurate answer, right? For doing the machine learning, we can able to do it with our simple CPUs. When we go with the deep learning, we should go with the general processing units for a better processing. So machine learning uses algorithmic models that enables the computer to teach itself about the context of visual data. If enough data is fed through the model, the data itself will teach one image to another image, which means that if more images are given, more inputs are given, the output will be very good. So algorithms will enable the machine to learn by itself rather than someone program them to recognize an image. A convolutional neural network helps a machine learning or a deep learning model to look by breaking the images into pixels, which means that the complete image is broken into pieces and the pieces are given to a machine, and the machine is able to learn those features and will give us an input. So we, the humans, are giving the inputs to the machine to learn and making them to learn and then give us an accurate output, right? The neural networks runs convolutions and checks the accuracy of it. So here comes the difference between the machine learning and deep learning. Machine learning and deep learning inputs are going to be the same. Whereas in the case of machine learning, we need to extract the features and we need to give it for classification. Whereas in the case of deep learning, the extraction of features are done automatically by the machine with the layers, and classification is also done in a combined way. So machine learning, very simple. Feature extraction is separated and classification is separate. Whereas in the deep learning, both are done together. We are increasing number of layers. You can see here we have 3 layers, whereas here we have 4 layers. Multiple layers need to be added there. So what is image processing? It is not a very new topic. So many of us know what is image processing. Just I'll give a brush up again. So image processing applies mathematical functions to images. The outcome of image processing may or may not provide a very detailed data. Hence, image processing does not require machine learning. For example, if I need to process the image, for example, if I'm taking a photograph through my mobile phone, if I need to sharpen it, if I need to sharpen the image, if I need to change the background of the image, I don't need machine learning or deep learning. So processing an image does not require any sort of learning. So much image processing, the main difference between the image processing and computer vision is, so image processing, we are taking the pictures, we are able to do anything for the pictures. There is no need for doing any sort of learning mechanisms. Whereas in the case of computer vision, we take the images, we process it, and then we make the machines to learn it. So hence image processing will not require any sort of machine learning. Instead, image processing will perform operations such as sharpening, smoothing, stretching, contrasting, etc. on particular images. So in our mobile phone, if I'm taking a picture, it is not required to do any machine learning or deep learning process. We can do all sort of operations. It is called as image processing. So what is the difference between the image processing and computer vision? Technically speaking, image processing will focus on processing the image. Both input and output are basically the images. So it will focus only on doing some sort of operations on images. For example, the main objectives of doing image processing may be smoothing an image, or sharpening an image, changing the contrast, brightness, and removing or adding the watermarking, calibration, compression, and edge detection. All these things we can do it with the help of image processing. Whereas coming to computer vision, it will focus on making sense on what a machine sees. For example, a machine, if whatever way I see on an image will be different from how you see on an image. The perspective, everyone's perspective is different. So computer vision focuses on making a sense of what a machine able to see. System takes inputs of an image and output task specific knowledge. It will give us an output about the task what has been assigned. So for an image, if I'm giving an image as an input, it will label the images and it will be able to identify what type of image is it is. For example, if I'm giving a cluster of images where images of a heart and eyes are present in the same cluster, the machine should be able to segregate the images of the heart separately and then the images of the eyes, lungs separately. So identification and doing some sort of actions and getting some measurements. If I need to measure some diameter of an retinal to optic disc to optic curve, then I can do it with the measurements, positioning, projection, all these things I'll be able to do with the computer vision. So image processing will focus on only processing the image, whereas computer vision will focus on making sense of what is there in that image. So it is very important to make a note. Image processing will process only on the image, whereas computer vision can able to make a sense of what image or what a machine able to see from that image. So what are the types of imaging and its applications? So we have various band of EM spectrums, electromagnetic spectrums like radio band, microwave band, infrared, visible band, etc. And we have various types of imaging. We'll see briefly about one by one. Like we have radio spectrum. In the case of radio spectrum, we have imaging type of MRI, magnetic resonance imaging, and it is used for broadly for computer-aided diagnosis. We call it CAD. Where the applications for this using MRI images, as we know, it is for diagnosis and treatment planning. And microwave images are used for ultrasound imaging, radar tomography, and it is again used in areas like agriculture. And mainly it can be used for diagnosis of tumor ablation and any properties of a food processing we need to do that we can do with the help of microwave devices. Whereas in the case of infrared band, it can be used for thermal imaging, where it can be used mainly for surveillance in non-visible spectrum. Surveillance through the infrared cameras, monitoring of temperature pattern, all these things can be used with the help of infrared. Similarly, visible. And all these things, this slide I'll be sharing with you. You can just go through this slide. What are the current trends in image processing? So the current trends in image processing are mainly objecting to as medical diagnosis and treatment and agricultural sector, monitoring of applications, and underwater image processing. Very important application. Very much research is going on underwater image processing. There's a large scope of doing research in underwater image processing now. Disaster management applications. These are the various trends currently it is happening in the case of medical image processing. In the case of image processing. So first one is medical diagnosis and treatment planning. So various applications I have given here. We can pick any one of these and then narrow down our research and then do something. And for the research community, first one is polyp detection. Automatically, if any polyp is happening, that can be detected using the colonoscopy images or video. Second, melanoma detection, whereas melanoma detection is about the skin, automatic detection and classification of skin lesions based on dermoscopic images. Everyone cares about the skin. So it is always good if you do some research, it will be very useful for the public. And retinal disease detection, like automatic detection of the retina or OCT using the OCT or retinal fundus images for diagnosing the diabetic retinopathy and etc. Now I have a question for audience. Can someone tell me what are the problems which can be detected using the images in the case of eyes? What are the problems we face which can be solved by image processing? Diabetic retinopathy can be detected. Anything else? Very good, very good. Retinopathy.
Retina issues.
Then retinal issues. Very good.
Glaucoma can be detected.
Eye nerve,
Very good, sir. Very good. Glaucoma can be detected.
eye nerves, swelling images also
Yes,
can be,
using the optic nerves. Very good. Optic nerves. Very good. So there are various problems with the help of retinal disease detection. Right? Right from the baby born, there is a problem for retinopathy of prematurity for babies. Okay. So right from the baby birth, we can able to stop these diseases, eye diseases. More than 40.
వస్తుంది సౌండ్ మాట వినిపిస్తుందా
Santosh sir, you are muted. Santosh sir, please unmute yourself.
సంతోష్ సార్
Sir, is it audible, sir?
Yes, yes, sir, you are audible.
Yes, sir. So audience are giving me some inputs. Right? Right, regarding the retinal diseases. Right.
అదేం
So Yes. So right from the kid is born, there are many retinal diseases which are happening. Right from retinopathy of prematurity, which is happening when the kid is of 8 to 9 months old. Right from there to working age groups, where we are having 47% of the people who go to retinal eye checkup for detecting diabetic retinopathy. The 47% of the eyes are almost in the gone stage. So we need to do something for doing the retinal research. And then coming to breast cancer detection, automatic classification of breast cancer based on microscopy images, and we have liver tumor detection, automatic detection of the liver tumor from new volumetric analysis. See, for each and everything, we have different set of images. The images of different types of images we need to take it and then process it. And then we have something called as brain tumor detection, where automatic segmentation of brain tumors based on ultrasound images. And we have something called as pediatric bone age detection. Here, the process is we need can able to detect the age, okay, based upon the skeletal age, based on the pediatric hand radiographs. These are various areas which need to be explored. Already there are a number of research articles there in this areas, but still there are a lot of research scope to do in the case of medical diagnosis and treatment planning. Coming to agricultural sector, agricultural sector is again a second important thing where we can do something on with the help of computer vision and image processing. The non-destructive analysis of seeds, where using the images of using the X-ray and MRI images, we can able to identify the quality assessment of the seeds, and we can able to do something called fruit grading systems. We can able to identify computer-based automatic fruits grading systems, because nowadays farming we are not able to concentrate much because we are concentrating on all other areas in developing algorithms, protocols, so applications, and all those things. When we can do something for the agricultural sector, which is the backbone of our country, it will be very much useful. And weed recognition we can do, and leaf segmentation, because we can able to find out some sort of diseases what are particularly for some leaves. We can able to take it and then diagnose those diseases and give some sort of solutions for those problems. And rice quality grading, again it is very important one, classification and quality grading of rice grain based on image techniques. There are many schemes which are coming on to research sector, like government is ready to fund a lot for the agricultural sector. Even now, one is there, I forgot that one. Okay. Regarding the containers, regarding greenhouse, how to preserve the greenhouse gases for the onion. If you just Google that, I'll give the link to sir, that there is a scope for doing the research on that one, and we can able to do something for that. Okay. Next one, monitoring applications. Like first one is pedestrian detection, second one parking occupancy detection, third one is traffic flow analysis. So always in our country, parking the vehicles is the biggest problem, and controlling the traffic is again a biggest problem. So when we can able to do something for this monitoring applications, it will be always good. Pedestrian detection, identify and locate the pedestrians in images and videos while considering variations related to how the bodies are moving or coming back. We can do with the help of the pedestrian detection. And parking occupancy detection, because we since we are not following any sort of parking occupancy, we are parking just like that, and then we are going inside somewhere, and it is giving a trouble to others also as well. So when we can able to detect the parking occupancy and then park the vehicles accordingly, it will save a lot of time for everyone, a lot of space also. Okay, visual parking lot occupancy detection, we can do it, and it will be very much useful in case of malls and in roads also. And traffic flow analysis, we can using the drone and camera based traffic flow tracking, and estimation have also been made possible. We need to thank for this computer vision technology. Because of the computer vision technology, there are many robberies are getting stopped. Right. Next is coming to underwater image processing. As I told you, this is having a very big scope, underwater image processing, like image enhancement, image noise detection, image defogging, image segmentation, image recovery, image saliency. All these things are already we have done for the images which are in the terrestrial images. Whereas in the case of underwater when we can do the same thing, and we can do a lot of things in the underwater image processing as well. So what are the next? Now, what are the research topics? As I told you, I'll discuss about the research topics in computer vision and image processing. So we have seen various applications where we can do a lot of research in the case of image processing. And what are the research topics, existing research topics? First one is seeing, modeling, and animating humans. Second one, scene structure and motion. Third one, computational imaging and video. Fourth one, learning and inference. And fifth one is augmented reality. I have divided them into 5 categories. One is regarding the seeing, modeling, and animating the humans. Second one regarding the structure and motion. Third one regarding the computational imaging and video. Fourth one regarding the learning and inference. Last one is regarding the augmented reality. So first one is seeing, modeling, and animating humans. So first one is neural phase and modeling and animation. So based upon some features, if suppose if I'm getting an image, that image is only half image is there. Based on that, I'll need to reconstruct the image. Then I can go with the neural phase modeling and animation. For example, in case of medical field, there will be some skulls maybe there. We will get the skulls off of the skull image, whereas we'll need to get the complete face. So we can rebuild that using the skull reading. Okay. Then volumetric video to animation, we can go with this, and you can go with the texture-based facial recognition and retargeting, and texture-based facial animation. The last one is modeling and capturing 3D shape and motions of humans. These are the various things we can go with animations field. Second one, scene structure and motions. Whereas how to detect an object, tracking the objects, and using the high resolution 3D reconstruction of the objects. For example, if I'm getting an image, how to do it in a 3D model, then sparse tracking of deformable images. If an image is broken down, okay, or if I need to do something on the fitness, we can go with the sparse tracking of deformable objects and reconstructing the 3D objects from the deformable objects. Again, is this an application which can be done. And the next one is computational imaging and video. Whereas with the help of a lot of video, we have so much of video. Processing an image is simple, whereas processing a video is not very simple task, because a combination of images will become a video. So video-based blood flow analysis we can be doing, and multispectral tissue analysis we can do, and surface tracking and infraction and texture space. See, I have given only a broader areas where we can just take something and then do some research and then get the inputs, and then we can proceed with our research. Okay, so regarding computational imaging and video, I have 3 classifications. One is video-based blood flow analysis, multispectral tissue analysis, or one is surface tracking and interaction texture space. And learning and inference, what the two I have taken, one is anomaly detection and analysis. Second one is deep detection of phase morphing attacks. This is becoming a very big fraud nowadays, like phase morphing attacks. Okay, so this phase morphing attacks can problem, we need to take it and then give some solutions for getting afraid of the phase morphing attacks. Last one is augmented reality, whereas nowadays the virtual clothing. So when we are seeing in the TV advertisements nowadays, with a small idea, we are able to see how our dress looks like, our shirt look like. Okay, that is virtual clothing. There's a very big research. So now I can able to do with the help of a shirt. If a lady needs to do the same for a sari, virtual clothing, we can do with the help of the augmented reality as well. Reconstruction and rendering of the human heads. So for example, the same thing as I told you, if a human skull is given, that how to reconstruct and render the virtual shoes. Now we have virtual clothing. We can also think of the virtual shoes. And as my concluding remarks, I would like to say that computer vision is a rapidly growing field in research and applications. Computer vision research are now directly and immediately applicable to commercial field. For example, now we have some where when we are doing some research, we can put our code there and it is directly having an impact in the commercial world. And AI developers are implementing computer vision solutions which will identify and classify objects and even to react them in real time. So as I told you, I'm not talking anything about the artificial intelligence. My computer vision will be a backbone for doing something on the artificial intelligence. So AI developers are already implementing the computer vision solutions which will identify and classify the objects and even to react them in real time mode. For this, I would like to conclude my remarks. I would like to thank you. If there is any requirements, you can just mail me. I've given my mail ID on my screen. I'll be sharing this PPT with the Kiran sir as well. If there is any queries, you can ask me. I've completed within 4:40. As my time is only 4:40. Little pressure. Yes, sir.
Sir, thank you so much for your wonderful presentation.
Yes.
Dear participants, if you have any queries, please unmute yourself.
Sir, I have few queries on the deep learning. You started the query like what is the difference, basic difference between machine learning and deep learning?
Yes, sir. Yes, sir.
I went through one assignment where I need to find product quality. I have to check whether the product is pass or fail. So based on that, yeah. So I have collected a number of shop floor operations parameters. So based on those parameters, I need to have the correlation like how these factors are playing a role in getting the right product, or it may be other way around. So I need to establish some relationship between the process parameters and the end result of the product. So I have applied this, algorithm. When I was applying, that is, feature extraction is one of the steps. As you rightly told in the discussion, the feature extraction is one of the steps has been carried out, and the algorithm will be taking care of extracting the features among, because in my case, it's almost 700, 720 parameters are there.
Correct, sir.
Are they audible? Yes. So out
Yes,
of
sir, yes,
7, I need to extract the main features, which is really contributing for my success of the product quality. So depending upon those parameters only, there are possibilities of going wrong, going a wrong product, getting a wrong product. I mean, defective product, or maybe a good quality product. So
correct,
how
correct.
do
It's a good problem, sir.
Yes, how do I go about in choosing the algorithm for feature extraction? Can you little elaborate on those things?
Yes, sir. See, the main objective in doing any sort of classification is the extraction of the features. So we need to decide which are the important features, and we should apply like in algorithms like a minimum redundancy should be there, sir, and maximum relevance should be there. You should choose an algorithm such that a minimum redundancy and maximum relevance should be there in extracting the features, because you will be extracting some 100 to 200 features. These 100 to 200 features may not be useful in getting your classified output. So we should apply
Yes, true.
applying algorithm like what are the minimum redundancy. So for example, if one and two will be looking same. So if these two fingers are same, which one is relevant? I should take it, right? So if I'm using these three fingers, these two fingers are there. Okay, this is not required, it's redundant one. These two are sufficient to detect my one finger to other finger, right? So similarly, you should use an algorithm like minimum redundancy and maximum relevance should be there in getting the output, sir.
Okay. Because
So there is
my
algorithm like minimum redundancy.
Yes, sir, correct. So when it comes to 700, 720, more than number of features, it is very tough
Yes,
for me to have a feature-to-feature comparison. So in a way, my test
sir.
goes a very lengthy time, So that is one of the main challenges I face. I couldn't, get the confidence level or accuracy level based on the comparing the features, because I should eliminate some of the trials so that I can arrive at best extraction at a quicker time.
Sir, have you tried the same algorithm? As I told you, MR, you just once try, sir. There's algorithm for MR. If you just type in Google, you'll get the algorithm for MR. Minimum redundancy and maximum relevance algorithm is there. So please try that algorithm once, sir.
Okay, sir. Okay. Thank you, sir.
The same algorithm you can try. Yes.
Thank you, Dr. Santosh. It's
Thank
really
you,
a
sir.
privilege to see you online.
Sure, sir.
Thank you. And
Thank you, sir.
Sunil, please.
Yes, sir. Sir, thank you so much, sir, for giving valuable insights in the topic, how we are going to be focused with the computer vision, the image processing. I hope, I don't know how much time it took for preparing this PPT. Really, it is very much connected to our participants, sir, because
Thank
you started with your agenda, like what is your computer vision. You mentioned the points, like how do
Yes.
computer vision works, what is image processing versus computer vision, and the types of image processing, current trends, and computer research topics in computer vision. So you focused with in a neat and a clear manner, and you already mentioned everything in a differentiative mode, like what is the difference between computer vision and human vision, how it is going to be differentiated, and exactly what is the differences between image processing and how the image processing is going to be different from computer vision, and types of imaging, and trends in the image processing, like where we are going work with medical diagnostics, agricultural, monitoring, some sort of applications. So like that, you focused a majority of the trending requirements, as well as you have given the current problem what everyone is facing, that is parking, how we are going to monitor the parking with the help of monitoring applications and all. Really, it is a very wonderful presentation, and I hope our participants have a feast with your presentation, sir.
Thank you, sir.
Really,
Thanks, sir.
thank you so much, sir, for joining with us. And once again, with the Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram, we thank you for joining with us and sharing your valuable insights, sir. Thank you
sir.
so much, sir.
Thank you, sir. Thank you, Kiran, sir. The opportunity,
Thank you,
sir.
sir. Dr. Santosh.
Thank
Have a
you.
nice day, sir.
Thank you, sir. Thank you, sir.